what your name is and try to talk about your chassis.
This is our robot for Team 4982, Cafe Bot. I'm Jonathan. And for last year's design, we're probably planning to use this year is this drop center drivetrain from Andy Mark. As you see, it has this cake drive. We're using 4 motors to 2 power outputs for our wheels for steering.
So, what's making this different? What's your new robot making?
This is actually our old robot. This is from 2 seasons ago, and it's Tandem 4-wheel drive. We really like that, but looking into future seasons, we're trying to use the tank drive simply because it's a Tandem. We have to level the weight so it's in the center. Whereas here, we can have weight more on one side, and we can do cooler things like this easier.
Okay, so out of everything you've learned between these 2 robots, what's like the #1 tip for teams?
Definitely prioritize your drivetrain. It's obviously really important. It should be the first thing you build and think about. And if it breaks, then you're essentially in trouble. So last season when we used this frame, we had a problem going over the barriers where the motors were shaking out. So we had to use Loctite to secure the motors. So really pay attention to your drivetrain. It's really not fun to show up 2 feet when all you can do is sit in the starting position.
I agree, yes. Any other questions?
I think that's good.
So tell me all your guys' names and what team you're from, and then about your choices.
I'm Thomas. I'm from 288 Spare Parts.
I'm Christian. I'm from 288 Spare Parts. Keyshawn from 288 Spare Parts. I'm Brandon, also 288 Spare Parts.
Perfect. So tell me about your chassis.
Okay. So chassis consists of the wheel, the tandem wheels, tandem wheels. Underneath, we have the Rev HD heavy motors on the ultraplanetary gear ratios. Yeah, 24. And they're chain driven. And the reason why they are in here, spaced out like that, is for space saving.
Yeah, we made a motor to mount them inside the wheel channel instead of normally we'd be here. And our full chassis laser cut wood, just because it's easier to prototype with. But this isn't our final design. We have a different one in a different room. That's our final. But this is multi-coil plywood, so it's pretty durable.
So what's one thing that's making your chassis different than everyone else's chassis?
It's made out of wood, so most of these other ones are made of aluminum, and some of them are like push parts, and ours was laser cut with the multi-burst plywood, so it was easy to transfer from our prototype designs.
Yeah. We use kit parts in a cool way. We don't use like the extrusion, but we use all the motors in hardware and stuff, so we need to get some.
So what's one tip that you give to you starting robot builders?
Plan out your design first, really.
Yeah, try to flesh it out as much as possible in CAD before you get.
Yeah, one of the reasons why this robot was so successful last year was because we basically modeled the whole robot in CAD before we started building anything to make sure that everything would like fit and we could hit dimensions and stuff.
Yeah.
Anything else you want to add about your chassis or tell the rest of the teams?
Isn't that plywood is a good choice?
I'm Myra, and can you tell me your guys' name, your team, and then about your chassis?
So I'm Emma, and I am with the Joebotics team, specifically the white team, which is 1998. And so for our chassis, for the white team, we went with a narrower build because the barriers in the wall, the gap. And so that's hence why it's a lot more narrow compared to this one, which will need to go over the barriers, not just the other keys. And then in order to spin the carousel to get the excellent, we also added this spinner in the back here. And then we also tried to come up with flipping mechanisms, like trying to get the blocks up to rotating shipping hubs, but that took a lot of trial and error. We had to make like 3 different ones, and we were kind of in a pinch. So last minute we had to make a few quick decisions, but then eventually we were able to make this one, which uses these to spin and forward them to the box, and then this will then lift. To then get up to the second tier of the shipping hub. We weren't able to get it to take in full balls, but it could take the box pretty well. And so that, yeah, and then before that we even had a different one where we had a box that would go down over the blocks and drag them around. That was it when we were able to bring that into the warehouse, was like, or the little block space. And then we also chose mechanism wheels, which was actually able to give a lot of ability to go forward, sideways, or all the different directions, which made driving a lot easier and more efficient.
Talk a little bit about the 75. Introduce yourself to the camera. Who are you?
My name's Maddie. And I'm the representative for the St. Joe Green team. So to start off, we base our program design on a striper chassis. We use mechanism wheels and we rotated the striper chassis, raised it a bit in order to get over the barriers. We used more of a claw-like arm, and it was able to span all the way out. Our original design, we tried to pick a place inside of the robot to keep inside the 18 by 18 cube. So we changed our entire initial design and moved it outside so that we had more room to rotate and move. Our wheels allowed us to move side by side without having to rotate the robot. We used one expansion knob, one control knob, and we have 6 motors.
And we had one tip we would want to give to new people making robots, starting one tip.
It's never gonna work out the first time. So like don't get disappointed, don't like be frustrated because there's always new things to
Speak loudly towards my camera.
So explain what this is for.
Yeah.
Last season, this one,
So
2 seasons ago.
theater department was doing the Beauty and the Beast play, and we were machine. They needed one, so we built them. One using parts. Lots of
Yeah. It also, if there's barriers on the
Tell me how exactly
I
you
think
built
you better
this.
going over just because
So
So we've
I don't remember what the measurements are, but explain how we got it to go up and down.
Yeah.
Look inside there and see how we got to go up and down. On a wheel. Right.
here.
Here.
So we used to gear a motor.
So make sure you sound over there, 'cause they've got some good
Connecting rod. And originally we had it
Laura's gonna sit backwards, Tech Tuesday emails, so it'll be in the Tech Tuesday. There's some surveys down in there, and they work when someone from your team comes to the coaches meeting, we've got some coupon codes and other systems. Pretty sure we said, but. So in the library, it's how.
Yeah, and what came out of here?
We'll see the stickers.
Okay, so I'm Amira, and you tell me your name and then what team you're from, and then about your chassis.
Hi, I'm Embry. I'm on P3. These are our 3 chassis we have today. This is our competition bot from last year. This is one of our demo bots. And this is a spare Go Build a chassis we have. This chassis is, like I said, it's Go Builda. It has a drivetrain with 2 Omni wheels and 2 regular wheels. There's 4 motors, and we don't have a hub attached right now, but it can drive. This is our Tetrix chassis. We don't use Tetrix for competition anymore because we prefer Go Builda. It has the same type of drivetrain as the spare Go Builder one with the 2 Omni wheels and the 2 regular wheels. We also have 2 servo extensions right here with little grabbers in front, simple mechanism. This is our complicated competition bot. We use a mechanism drivetrain so that we can strafe forwards, backwards, makes it easier to move around. We also use chains connected our motor to our drivetrain. We also use higher RPM motors for our competition bot so that we can move faster. You want to hear about the extensions too?
I'd love to. Yeah.
So our simplest extension is the delivery guy here. It spins and we have a nice Walter Panda. This is to deliver the ducks by spinning the carousel. And this is our, I forget what this one is called, but it can unfold, and we used 3D pliant extensions to pick up blocks using a servo motor. And this can also lift up using a motor. And this elevator slide that we're using for this. And we actually went through several iterations to find the right intake mechanism. We decided on 3D printed stuff instead of, we were originally going to use surgical tubing, but we couldn't find the right appliability for it. Any more questions?
Yeah, so I've asked everyone else, what's one tip you would give to new robot builders?
Sometimes even the simplest things can take a lot of different versions to work. Like, you think that these spinners would actually be really easy to make, but we had to go through a lot of different versions to get ones that would actually hold the block.
Okay, yeah, and that's all. Thank you so much.